Hello, this is Ms. DB, and in this lesson we're going to review how to do compositions of transformations, which is when you do more than one transformation after another. This is from Chapter 12 on Transformations, Section 4. Our objectives are to apply theorems about isometries and to identify and draw compositions of transformations such as glide reflections. A composition of transformations, like I said, is just one transformation followed by another. There's a special one called glide reflection that is used quite often, and that is when you have a translation and then a reflection. And generally speaking, that is across a line parallel to the translation vector. So like if you were going to translate 3 units to the right, and then reflect about the y-axis, that would be a glide reflection. Here's an example. We're starting with the pre-image, the blue triangle JKL, and then the next thing that happens is there is a translation along the vector, so you can see that it's moving to the right, and that is the green dashed one. And then it is reflected across line L, which is then the image of K prime L prime J prime K prime L prime. So first a translation, then a reflection is called a glide reflection. This is an isometry, which means that after each transformation, the image is congruent to the pre-image. And there's a theorem that actually says that a composition of 2 isometries is an isometry. Simple little theorem. All right, we won't be doing this on the assignment. Again, it's just very difficult in the online world to draw by hand any transformations, but especially when you have more than one going on. But if you were going to, this is what you would do. If we started with the quadrilateral PQRS, they want us to first reflect it across the line M, and then translate it along the vector V. So the first thing you would do is the reflection, which is just flipping it over that line, and then you would take the green, the image P prime Q prime R prime S prime, and move it along the vector V to find the final image, which then would be P double prime Q double prime, R double prime, S double prime. So 2 apostrophes after the capital letter of the vertice means that it has been transformed twice. All right, we will be doing this, where we will be doing them in the coordinate system. Again, I highly recommend doing these in Geometer Sketchpad. Way easier, fast, don't have to worry about, scanning in your work. You can just do it and then save your Sketchpad file and attach it to the assignment. All right, so we're starting with a triangle, KLM. It's got the given vertices, and you would plot those on the coordinate system first. Next thing we want to do is rotate that 180 degrees about the origin. Now, we learned in the last section, 12.3, what the rule is for rotating 180 degrees, and it was to take the opposite sign of both the x and the y coordinates. And then they want us to take that image and reflect it across the y-axis. So you'll have 2 transformations to complete. First, we will write the rules on how to rotate 180 degrees. And there's the original coordinates KLM of the pre-image. And then the rule is to take the opposite signs, and we'll get K prime, L prime, M prime. And then we are going to reflect that about the, was it the y-axis? The y-axis. And the rule for that, you have to look back into the first section of this chapter, is that when you reflect about the y-axis, you change the sign of just the x-coordinate. So here's our first image. And I would do these I would sketch these as soon as I figure out the transformation. So I'd start by sketching the pre-image. Then I would figure out what the rotated 180 degrees is, and I would sketch that. That's K prime, L prime, M prime. Label the vertices with the capital letters that match the pre-image, but with the apostrophes after it. And you say that as prime. And then I would reflect it over the y-axis, which is the red. That is the image, the final image, and you would put the vertice labels would have 2 apostrophes after them, and those are called double prime. Here's another example, and again, you'll be doing some of these on your homework. We have the given vertices for J, K, L. This is a triangle. This time we want to reflect first about the x-axis and then rotate it. You need to do the transformations in the order given. So first we would put J, K, L on there. Then we will figure out where will the reflection be about the x-axis. And the rule for reflecting about the x-axis is that the x-coordinates will have the opposite sign. Wait. Across the x-axis should not have, the y-coordinate should be the opposite sign. So either they made a mistake in labeling the question or in the rule. Let's see, which did they do? They're reflecting this about the y-axis. So I should have checked more carefully for mistakes. This is a PowerPoint from the textbook. They're reflecting about the y-axis because that rule is that all the x-coordinates would have the opposite sign and the y-coordinates wouldn't change. If you reflect about the x-axis, which is the horizontal one, then the x-coordinates stay the same and the y-coordinates would change to the opposite. All right, so first we are reflecting over the y-axis, and then we are going to rotate that 180 degrees, which you change the signs of both of them. So we're starting with the original. And then reflecting over the y-axis, like I suspected, and then rotating 180 degrees. You change both of their signs, and you'll end up with, I guess it would be K double prime, J double prime, L double prime. However, they drew that in the wrong spot. Do you see that? If you're rotating this 180 degrees, you would change all of their signs as they did, and you would end up with, I'll use red, as they did, 1, 2 is right here, 4, 2 is right here, and what? Sorry, I have to start over here. And what was our last one? 3, 0. So that is where the triangle should be. So the mistake on here is that they had reflected over the x-axis in their thought process and then rotated. I don't know what they did, but this is where it should end up. All right, so now, as you may have realized, you can put compositions of functions can sometimes be simplified into one transformation. So the composition of 2 reflections across 2 parallel lines is equivalent to a translation. For example, if you took the blue triangle and reflected it over this line, you get the green one. And then if you reflected that over the second line here, which is parallel to the first, you end up with the red triangle. That's the same as if I just went a translation that far. So sometimes compositions of functions could be simplified into one transformation. If you take, if you have 2 reflections across 2 intersecting lines, that's the same as rotating. And the center of rotation is right here, the intersection of the lines. That's how many degrees your rotation would be. The angle, oh, sorry, that's the center of rotation. The angle of rotation is twice the measure of the angle formed by the lines. So if this was a 50-degree angle, the angle of rotation would be 100 degrees. Rotation. Okay, let's look at an example of this. We have the design reflected across line P and then again across line Q. Now you have to know if line P and Q are parallel, which now that we see the image, we see they are parallel. These arrows here tell us that they're parallel lines. So first it's being reflected across P and then reflected across Q. What would be the single transformation that moves the design from the original position to the final position? And the answer is that this would be a reflection. And it would be twice, I don't know if I said this on the last page, but it would be twice the distance between the two parallel lines. So the translation vector would be 10 centimeters to the right. So if you had to write it, it would be, as a vector, it would look like that. All right, this goes along with the book example. If you reflect this twice over N and P, and they're parallel lines, and the distance between those parallel lines is 3, then you would end up with a translation. That's part of the answer, that you have to say translation, and the distance is 6. Any translation or rotation is equivalent to a composition of 2 reflections. So you can rewrite a translation or a rotation as 2 reflections. Sometimes it's a little bit simple to find that, and sometimes it's a little trickier. This one says to copy each figure and draw 2 lines of reflection that produce an equivalent transformation. So we show a translation from XYZ to X prime Y prime Z prime. We just saw how you could reflect it over one line and then reflect it over another line equals a translation. You won't have to do this on the assignment, but it's kind of interesting to see how it goes. So you would start by drawing a line between Y and Y prime, and then find the midpoint. And then you would do a perpendicular bisectors of YM. So from here to here, this section, draw the perpendicular bisector, and then from MY, draw another perpendicular bisector. Now, we learned about this in quarter 1, how to make perpendicular bisectors and midpoints and things like that. You could do this in Sketchpad, because then you can actually just select the segment and go to construct midpoint, and you can also construct a perpendicular line through the midpoint, which is the perpendicular bisector. Doing this by hand, you would need a compass and a straight edge. So those were the 2 lines of reflection. Those 2 lines that end up being drawn, the 2 perpendicular bisectors. Here's another example. This is a rotation, and to find its 2 lines of reflection, you would draw angle AP. Where's P? Oh, P is the center. So you would draw AP and then A prime. Here's the nicer looking one. So you draw that angle, and then you bisect the angles. And again, we learned that early on in this book. And then the bisectors of the 2 angles are the 2 lines of reflection. So PC and, oh no, that's not PC. So this line and this line are our lines of reflection that would result in that rotation. All right, so we won't, like I said, we're not going to be doing these on the assignment, so I'm going to move past the check it out. Too tricky to do by hand. Even if we were doing this in the classroom, we would probably not do these particular ones except as an extension or as kind of an extra thing. But it's good to know that it is possible to take any translation and redo it as 2 reflections, or to take any rotation and redo it as 2 reflections. It's kind of interesting. So focus on the first part of this section for sure. Composition of functions. You do both transformations and one after the other, and that's about it. Have a great day. Thank you very much.